Welcome to part 1 of Makerlessons' Ohm's Law series on voltage. Voltage was discovered by Alessandro Volta, and his discovery was published in a letter to the Royal Society in 1800. An Italian physicist, chemist, and pioneer of electricity and power, he is credited as an inventor of the electric battery. One of his biggest contributions to the study of voltage was the voltaic pile, which he invented in 1799. A voltaic pile is two dissimilar metals stacked on each other with an electrolyte separator, which is a conductive barrier between the metals. When stacked like this, one metal will want to remove electrons and the other will want to receive them. A single set of these metals and electrolyte sheets is called a cell. This invention is an early precursor to the same technology we use in batteries today, and why sometimes we call batteries cells. With this invention, Volta proved that electricity could be generated chemically and debunked the prevalent theory that electricity was generated solely by living things. For these achievements, the volt was named after him. Voltage is defined as the difference in electric potential between 2 points. Voltage is also known as electric potential, electric pressure, and electric tension. Because of having these multiple names starting with the word electric, you will sometimes see voltage represented as a capital E in some older textbooks. Today we commonly use the word voltage, or volts, represented as a capital V, since E is typically used for energy. When looking for total voltage in a circuit, you're actually looking for the total change in voltage between the positive and negative terminals. This can be represented by delta V. For simplicity's sake, we often use V without the delta when annotating a circuit because this is understood. When talking about voltage or electric potential and pressure, it is easy to make an analogy to water, because water also has potential energy and pressure, and we can see it, unlike electricity. Water towers create water pressure by being built on higher ground than the homes we live in. Water towers take advantage of the potential energy created by this difference in height and can be calculated with the formula potential energy equals mass of the water times gravity times height. If more water pressure is wanted by engineers, they can change the mass, or the amount of water, or the height of the water tower. By changing either of these two, they can create the needed water pressure for the homes nearby. Focusing on just the amount of water in the tank makes the comparison with voltage even easier to see. Think of voltage as the amount of water in the tank. In this example, everything else in the system will stay the same, so if we adjust the amount of water, voltage will change. Here, our tank is almost full. Notice the pressure gauge on the pipe as the water flows. With the water tank mostly full, the pressure is high. However, when the level of water is lower and the amount of water is less, the pressure shown on the gauge is also lower because the water has a lower potential energy. If we replace the water with voltage, we could continue this analogy. Imagine each orange circle is equal to 1 volt. Looking at the full tank of voltage, we can read the gauge. However, the measurement tool we use for measuring voltage isn't a water pressure gauge. It is a multimeter, which reads electric pressure. With a full tank of voltage, our gauge, the multimeter, can now read the voltage as electric pressure. This is the amount of force each volt is actually pushing through our pipes, which represent a circuit. As our tank of voltage is lower, so is the measured voltage from the multimeter, because just like the water, the electric pressure is less. These same measurements of voltage, or electric pressure, can be measured off a battery. In this case, let's use a AA battery. Each AA battery measures 1.5 volts in real life. As we know from Volta and his voltaic pile, the inside of each battery is made up of cells. Depending on the material, each cell will produce a specific voltage, and when the cells are stacked on top of each other, the voltage will increase. We can see this when we stack 2 AA batteries on top of each other. When we do this, the voltage will read double because we are effectively doubling the amount of cells in the stack, or, to bring it back to the water example, doubling the amount of water in our tank. Here is an experiment you can try at home. In this experiment, you can make your very own voltaic pile or simple battery just like Alessandro Volta. We can create a voltaic pile by stacking 2 dissimilar metals together and separating them with an electrolyte. At home, you can use pennies made from copper and nickels made from copper nickel, separated by paper towels made damp from lemon juice or vinegar to act as your electrolyte. You can measure the voltage from your voltaic pile by using a multimeter. Challenge yourself to get the highest voltage you can by experimenting with different coins or objects made from different metals like zinc washers or a quarter made from nickel, or by stacking your pile as high as you can. Remember, the more cells you have, the more voltage you will be able to create. Remember to like and subscribe if you liked this video. Thank you for watching.